Hello, this video will present a new scientific discovery in the field of digital signal processing that basically kills atheism once and for all. Discovery in short is that the frequencies of sound waves of Hebrew words look like Hebrew letters. We first talk about the digital signal processing software that was used for this discovery, and about DSP in general. DSP stands for digital signal processing, of course. Then we'll show some of the results of the software, and finally we'll explain why it is scientific according to the Karl Popper's test of whether sound theory is scientific or not, which is basically the falsibility of the theory and why it kills atheism. First of all, this is the link for the software, the version of victory.codeplex.com. Anyone can download the software, and anyone that knows how to program in C# can also download the code using Git, and see for himself there is no funny business in the code. We're going to use this paper which I wrote in Hebrew, which presents the discovery. Going to use it as a reference for seeing some images from the software quickly. First of all, talk a bit about the digital signal processing. Digital signal processing is the field of processing digital signals, as its name suggests. In particular, sound waves, when recorded by a microphone in the sound card, form a digital signal. Using the FFT algorithm, which stands for fast Fourier transform, one can find the magnitude of different frequencies in the sound waves of a recording saved as a WAV file. Using the short time Fourier transform, which is STFT in short, one can run the FFT algorithm in short windows, and this way one can find the magnitude of frequencies in each window. Once the magnitudes are found, one can draw a graph when the x-axis is the time, or actually the index of the window, and the y-axis is the frequency, such that higher frequencies appear above lower ones. One can also give colors to points in the graph according to the magnitude of that point, which is identified by its time, which is the x value, and by its frequency, which is its y value. Because the SFTFT algorithm gives a magnitude for each tuple t psic f, when t is the x and f is the y. The paper, which we're going to use as a reference, it is written in Hebrew, it presents images that were cut from the graph of the software using rectangles. Each image is the shape of a rectangle, and using the recordings of the names of the Hebrew letters. For example, this image was cut out of the graph that was basically found using the STFT algorithm on the Hebrew letter Aleph. I just recorded the word Aleph with a regular microphone and ran the algorithm, and this image was cut from the graph. This image was cut from the graph of the letter Beth. This is the letter Gimel, Dalev, He, Waw, and each of the Hebrew letters, using its name and the STFT algorithm, it was able to retrieve all the shapes of all the letters, which is what I said in the beginning. The frequencies of the sound waves of the Hebrew letters look like the letters. Each letter looks like the name of that letter in this graph. You can see this is the letter Ayin, letter Pe. This is the end Pe. Some of the Hebrew letters, when they appear at the end of words, they have a different look. This is when the letter Pe appears in the middle of a word, and this is when it appears, this is its shape when it appears in the end of the word, of a word. This is Sadi, and Sadi, Kuf, Resh, Shin, Sin, and Taf. All the left images are the Ashuri letters, which are the letters of the Hebrew Torah, and the right images are taken from the software. These images were given in a random order to Israelis, whose natural tongue is Hebrew, of course. And 13, it was a very small experience, but 13 out of 15 people correctly recognized all the 27 letters, which proves that these are actually images of the letter themselves. A person that knows Hebrew can easily see the resemblance. Person which doesn't know Hebrew, maybe it's a bit difficult for him, but I think the similarity is still manifested in the images. So this is the software. This is how it looks like. And anyone that will download the software will get a library of recordings that I recorded, because the accent is very important. So someone that doesn't know the Hebrew accent, or more specifically the accent of the Sephardic Jews, might not be able to find all the letters himself. So I prepared a library of all the letters. This one is the letter Aleph. When I click here, I run the STFT algorithm on a recording of the word Aleph, and what I get is a big Aleph, and inside of it, a small Aleph. This Aleph is actually this one. Here, and in the paper I explain it more thoroughly, we see that the letter doesn't appear only once, but it appears a few times. Sometimes one appearance of the letter is above another, sometimes it's one inside the other. But I was able to find the shapes of all the letters in a way that were recognized by Israelis. This is the Beth, like we see here. Again, this is the STFT algorithm ran on the recording of the word Beth. This is, see, there are a few examples of the letter Gimel. This one I think is the best. Since this Gimel, by the way, one of the features of the STFT algorithm is that the higher half of the graph is always a mirror, a vertical mirror of the lower part of it. And here we see the Gimel in the lower part of the graph. You can see this part of the Gimel, which is exactly like, well, similar to what it should be. We also see here the three line that should be above the head of the Gimel, and this actually works for all the letters. You can see here Daled. This is the shape of the letter Daled. You can see it here. If we skip a bit to the middle so I won't make this video too long, we can see here the Mem. It's the shape of the letter Mem. See this one? It's like this. You can see a bit of a mess in its right, but using a different recording we can see a bit less mess, and you can see this Mem, which is also recognized by Israelis, and you can also see the shape of the end Mem, which is the shape of Mem when it appears at the end of a word. This is the Mem. This is where previously we saw the regular Mem. This is the Mem in the end of a word. We can also see, skip to the end, you can see a few examples of the letter Shin. When I say Shin, I record a WAV file and run the SSE algorithm. You can get this Shin, which is very similar to what it should be. You can see it here in the article. This is Shin. This is how Shin should be. So it should look like, and we'll see it for the letter Taf before we continue on. So this is the shape of the letter Taf. You can see here the shape of it when I made it smaller and put it next to the real Taf. You can see the resemblance. This one is for the software, this one is the real Taf. This is not the end of the discovery, because it not only works on Hebrew letters but also on Ta'amim. Ta'amim are special signs that tells the reader of the Bible how to sing the sentences. For example, there is a Ta'am called Darga, and Tevir, and Tarha, and Siluk. And if we have a sentence in the Bible that is darga with the darga sign, and tavir with the tavir sign, tarcha with tarcha sign, and siluk with the siluk sign. It will sound like this. Darga tavir tarcha siluk. This is how we sing the Torah and the Bible. We can see in Wikipedia how darga should look like. You can see here, if I zoom in a bit, this is the darga. It looks very similar to the letter S. When you run the TFC algorithm on a recording of the word darga, without the melody, just the word darga, we can easily get this graph. And we can see here the darga. And actually when I discovered this, I asked my wife to take a look and tell me what Latin letter she sees here. And she refused. She said, no way it works for Latin letters, only for Hebrew letters. It took some convincing, but then she agreed to look and told, okay, it's an S. Told her, don't worry, Hebrew is special. It's not an S, it's darga. If you look how S looks like, for example, this is S, we can see that it doesn't look anything like an S. You can see this is maybe something like the letter Het in Hebrew. This might look like a bit like the letter N in Hebrew. In any case, there's no S to be found here. This is not when the wonder ends, because not only we can find Ashuric letters in the sound wave of the letters, but we can also find different types of Ashuric letters, and I'll explain. There are the types of Ashuric letters of the Sephardic Jews. There is the type of the Ashkenazi Jews, which are the Jews from Europe, and there are types of the Yemen Jews, and they are very similar. Usually Israelis can easily read all the types, but they have a few differences. For example, this is the letter Zayin according to the Ashkenazi Jews, and this is the letter Zayin according to the Sephardic Jews. And we can see that both types can be found in the software, also for Yod, and a lot of letters. I was able to find both types of the letters using different recordings. For example, this is the Lamed, the letter Lamed in Hebrew, and this is how it should look according to Ashkenazim, and this is how it should look according to Sephardic Jews. Both of them are from recordings of the letter Lamed. Here we can see the Mem. You can see here how the left leg of the Mem ends like this, and you can see when it ends a bit forward, like here. It's less easily found, but here it's more easy to see that here the head of the letter Nun is a bit straight, and here it's a bit on the diagonal to the top left, like it should be according to Sephardic Jews. Can also found the same thing with the letter Shin. This is Shin that resembles the Shin of the Yemen Jews, and this more resembles the Shin of the Sephardic Jews. You can see it comes from the left head of the Shin, and here it comes from the base of the Shin. Here it's like the Yemen Jews, here it's like the Sephardic Jews. This is not where the wonder ends, because even just general words in Hebrew, they also look like Hebrew letters when the STFT algorithm is ran. For example, this is the frequencies graph of the word Shabbat. Shabbat is called Saturday in Hebrew, and you can see here, Israelis can recognize it easily. I checked it. This is the letter Kuf. We can see here how it should look like. If we go to the top, look for Kuf, we can see that this is Kuf. This is the word Kuf, and this is the word Shabbat. It also looks like a Kuf, but actually Kuf is the first letter of the word Kodesh. And Kodesh means holy in Hebrew, and if actually we look how Kodesh looks like, it looks like Shabbat. It looks like Shin, sorry, which is the first letter of the word Shabbat. It also have like the 3 lines on the top that are supposed to be in the Ashuric letters. So it's definitely a Shin. So this is about the software. Now we should say that the software is not straightforward. I mean, not every time I'll say the word Kodesh, I'll get this shin. There is a very common use case with digital signal processing, and it is to use some kind of a filter. The filter is usually something that is used on the signal itself, but here I'm using a special kind of filter, which doesn't work on the signal itself, but it works on the image. Each point in the image gets some value according to the magnitude that the STFT found of the frequency. For example, here we have the x-axis is the time, the y-axis is the frequency, so this point represents a higher frequency than this point. And each of them has some magnitude, and the filter determines what magnitude will be presented in the graph and what magnitude will be hidden. For example, here, actually every point has some magnitude. So if I present all the magnitude, the whole graph will be colored and we won't see anything. So we only present some of the magnitudes, and here we present a subset of the magnitude that gives us a sheen. This means that we need to play a bit with the parameters accordingly to get this sheen. But it doesn't mean that you can get anything that we want. What I mean is that for the letter shin, for example, I cannot get the letter bet. I can only get some kind of a mess or the letter shin. Sometimes I can accidentally get a different letter than the one that I said in the recording, but it is just accidental, and actually only one of the letters appeared many times, and anyone can download the software and see for himself that this is true. And when we'll talk about the argument which kills atheism, we'll see how it handles the fact that we need to play with parameters. Okay, so now we're going to talk about the argument and explain why this discovery kills atheism. So I'll use the paper as a reference so I won't forget any step of the argument, but it's actually pretty easy. I didn't say, but I actually took the letters and formed some sentences from the letters, and Israelis usually can read easily the sentences. I tried it with a few sentences, and most of them or all of them worked really great. So first of all, before the argument, we're going to say why this is scientific. Because you know, the Karl Popper test for scientific theory said that a scientific theory needs to be falsifiable, such that if we get a contradicted fact, it weakens the theory. And if we get enough contradicting facts, then the theory itself is contradicted. For example, the theory for gravity of Newton was contradicted because there were found some stars that do not move according to the formula of Newton. Then came Einstein and formed the general theory of relativity, which replaced the Newton theory. So in order for our argument to be scientific, we need it to be falsifiable. So first of all, using the experiment of presenting the letters to Israelis and the sentences, we established that these images are actually images of the letters themselves. The weak side of the argument is that we need to play with the parameters in order to get the letters. So theoretically, we can say Aleph and get a Shin, or say Shin and get an Aleph, and then if we get this, then it means that Aleph doesn't look like an Aleph specifically, but it may look as an Aleph given the correct parameters. But in order for our argument to be valid, we need to form it in a way that we have a match, that the sound waves of Aleph looks like Aleph, sound waves of Beth look like Beth, and etc. So what we say is this: any word, any name of the letter draws the letter. We are not saying that it draws only the letter, but it definitely draws the letter, and we establish this using the experiment with the people and the sentences. Now, we'll say this argument that says that given a name of a letter and the name of a different letter, if letter A matches the name of the letter A, then the best appearance of the letter A will be found when we say the name of the letter A. If we say a name of the letter B and we find a better appearance of the letter A, which can be overtopped by the name of the letter A, then it means that our theory is falsified. So here we see the letter Aleph, which we got from a recording of the word Aleph. If we can say Beth and play with the parameters to get a better looking Aleph, then it falsifies our theory. I played with the program a lot of time, and can tell you that the best Aleph is we get it only when we say Aleph, and actually I don't think we can get an Aleph given any other name of a letter. And also when we say the name of the specific letter, for example, we say Nun, we get a lot of appearances of the Nun, and we can get them easily. While if we try to say Nun and get an appearance of a Beth, which is a bit similar to Nun, then we might get it accidentally, and it won't look like this Beth, and it won't appear many times, but only one time or 2 times by accident. So this is the reason that the argument is scientific, because it can be falsified. Anyone can take the program and try to find better appearances of the letters which we found using the wrong names. You can find anyone can find the images here, therationalvictory.com/hebrew.html, and you can get the software here, therationalvictory.complex.com, as we said. So it is falsifiable, which makes it scientific. Now we'll say why it scientifically kills atheism. The probability of having a match between the name of a letter and its shape is very, very low. Now, we cannot compute it directly because it will be very hard mathematically, but what we can do is assume that we have the 27 shapes of the Hebrew letters, and we have the 22 names of the 2 Hebrew letters, because we have 5 letters that have 2 shapes, one when it appears in the middle of a word and one when it appears at the end of a word. And we can compute the probability of getting a match. If someone just takes a name and tries to patch it into some shape, he have 22 multiplied by 21 multiplied by 20 attack ways of choosing shapes for the name of the letters. Then he needs to choose 5 letters that will have 2 different shapes. One when it appears at the middle of the word, and one it appears at the end of the word. Actually, the probability of getting a match this way is about 10 to the minus 25, which is ridiculously low. Ridiculously low. Now we should say something about probability. The only reason we know about gravity is probability, because no one ever saw gravity. No one ever heard gravity. All we ever saw is stuff that fall down and stars that go around other stars. So when we have a formula for the gravity, for the theory of gravity, we can check how many stars are rotating according to this formula. We can check how many objects fall down according to this formula. And if we try it enough times, we can empirically prove that the formula is correct. So meaning that nature acts according to that formula. In theory, even if we check like 1 million times and the formula is correct all the time, there's still a chance that we have a probability of half that an object will actually float or go up, and only a probability of half that it will fall down. And accidentally, during all the history of all humanity, and all the stars act according to the law of gravity. The probability of this will be very, very low. Because it is very, very low, we know that it's not accidental, and objects do not fall down accidentally, but there is a natural law of gravity. In the same way, because the probability is so low, and we need to say that, for example, the number of seconds since the Big Bang, according to the Big Bang theory, is about 10 to the 18. So even if each second someone would try to find a match between a name of a letter to it and its shape, there is still only a chance of 1 to a billion that even one of them will succeed. So this chance is ridiculous. It's like much less than a chance of winning the lottery. And this actually proves that the one who matched the name of the letters to the shape of the letters, he did it knowingly. What do I mean by knowingly? I mean that he knew that the name of a letter matches the shape of the letter. If he didn't know this, it would just be accidental, and then it will be subject to the theory of probability, and we'll have a very, very low probability. So it means that it wasn't accidental. Once something is not accidental, the probability that it happens randomly is irrelevant. So now we established two things. One is that the name of the letters in Hebrew match the shape of the letters, and we established that it cannot be accidental. Now we should say that the only way to know about the frequencies graph of the letters, I mean to know that, for example, if we take the letter mem again, the only way to know that the word mem looks like this in the frequencies graph is to have a computer and a microphone to record the word mem and then to run the STFT algorithm. It cannot be done without a computer. Now one might think that it's possible to see that the shape of the sound waves in water, in sand, in anything like that. No, it's impossible because this is not the shape of the waves. It's the shape of the frequency of the waves, and the only way is to calculate the STFT algorithm, is to run the STFT algorithm on a recording, and it cannot be done without a computer. Now, the people who lived like more than a few tens of years ago did not have computers. Anyone can check all the archaeology discoveries and see that no one ever found a computer or a motherboard or a processor or a screen or anything like that. They do find a lot of bones, but no computers. And of course, bones, actually no one really think that people had computers. It's a new technology. We are at the top of the technology of the human race since it exists. So what we established so far is that the one who matched the names of the letters to the shapes had to know about the graph, but people did not have computers, so they were unable to know about this graph and how the names of the letters looks like in that graph. Now this means that the one that matched the name of the letters to their shapes was not a person. It might come as a shock to atheists, but it cannot be a person because the name of the letters in Hebrew they appear in books that are way more than 2,000 years ago were written, and in the Bible they appear, which was definitely written more than 2,000 years ago, and also the shape of the letters are much older than the time we have computers. Now, under the assumption that the inventor of the Hebrew language, or at least the one that matched the names of the Hebrew letters to their shapes, was either a person or God. It cannot be a person. It proves that the inventor, that the one that made the match between the Hebrew letters, their names and their shapes, was God. It also proves something else, which is the prophecy. Because if God invented the Hebrew letters, or at least made the match between the names and the shapes, how did it get to people? I mean, any book in Hebrew is a strong evidence that we do have the letters and we do know the name of the letters and we do match them to their shapes. And the only way we could know this is if God told us. And for God to tell us it simply proves that there would have to be at least one prophet which God told him the name of the letters and their shapes. Now anyone knows that atheism is dead. This is scientific because it is falsifiable. Anyone can download the program, try to falsify the theory. All he has to do is say Beth and get a better appearance of Aleph or of Gimel. If anyone cannot do it himself, he can watch in YouTube. Find in YouTube, actually, you can find in YouTube some, look for the Rational Victory in YouTube and you'll find some movies that I recorded where I find the letters. Anyone can see how easily the letter Gimel can be found and the letter Shin. This is what I recorded until now. And anyone can see that it is pretty much easy. And when I say Shin, I'm not getting an Ayin or a Pei. I just get Shin. When I say Pei, I just get Pei, etc. Now we're going to see something else that is pretty amazing. This in my opinion. This is the frequency graph of the word menorah. Now menorah is a lamp. It was in the temple. It is said in the Torah that it has 7 candles. About 20 people, I sent this image to about 20 people, and a bit more than a half of them said spontaneously, without me telling them anything, that it is a picture of a menorah, or a Hanukkah actually, which is pretty much very similar to a menorah, but it has an extra candle. It has 8 candles, but here we can see only 7 candles, but we don't see menorah in our day-to-day life, but we do see Hanukkah every year in Hanukkah. So if we had here some picture of Picasso, we can know for sure that no one would say that he sees a menorah. So this actually proves that we see a menorah. And here, if someone has a hard time to see it here, I prepared an edited image. Of course, the people of the experiment did not see the edited image, they only see the original one. You can see here the menorah, and it also appears in this graph. So the inventor of the word menorah, he knew what he was doing. And actually this is the frequencies graph of a sentence in the Bible, which goes like, זה מעשה המנורה, which talks about the menorah, and it also has 7 candles. It's a bit less nice than this menorah, but still more than half of the people that I presented this image to, they spontaneously said they see a menorah or Chanukiah. Again, it's not the Chanukiah because it has only 7 candles. 4, 5, 1, 2, 3, 4, 5, 6, 7. I should also say that any word in the Bible in Hebrew draws some letter in Hebrew in this graph. I've now started working on finding all the letters. Maybe I can show an example. Of this one. For example, this is the letters of the first sentence in the Torah. בראשית ברא אלוהים את השמיים ואת הארץ. This is how it looks like. The first letter is Het, the second is Pei. This one is less accurate, but it is the Lamed. This is a Lamed, this is Shin, Lamed, and Kuf. And Israelis recognize those letters. Again, it proves that not only the inventor of that God did not only made the match between the name of the letters and their shapes, but he actually created the shapes themselves, because they look, they are found in the figurative graph for any word in Hebrew, except menorah and the names of the ta'amim, which looks like any ta'am looks like the sign of that ta'am, like we saw with darga, which looks a bit like an S, and menorah looks like menorah, but any other word that I tried looked like one of the letters of Hebrew. That is it. Now I should say what it doesn't prove. It doesn't prove the Torah, it doesn't prove Judaism, it doesn't prove Christianity, it doesn't prove Islam, but it does contradict atheism. Thank you very much, and shalom.